Hello guys, and welcome to my channel. Now in this video, I want to talk about the properties of radicals, okay? So I'll just put it down, the first one for you. Now, when we have the square root of two numbers being multiplied together, right? That is the product of two numbers. Okay, let's make it very general. Let's say the nth root of that. And you know, for us to take n as the index here, it must be a positive whole number which is greater than 1, right? Positive whole number greater than 1. Okay, so this right here is the same thing as the nth root of a times the nth root of b. So the nth root of the product of two numbers is the product of the nth root of those numbers, right? Okay, very nice. So maybe let's check some examples under that and be clear with it anyway. If we have to take the square root of a certain number, for example, let's say 12, all right? So we can rewrite this 12 into into factors, okay? Let's say we want to write it as two factors. Let's actually take the two factors. For example, 6 times 2, and 4 times 3, even 12 times 1. Well, I'm not going to take 12 times 1. Rather, I choose to take, I write it as 6 times 2. Alright? So we are saying that when we have the product of two numbers, then it can be taken this way. So this means the square root of 6 times the square root of 2. Like that, alright? Okay, we can also choose to take square root of 12. We can also view it as square root of 4 times 3. Okay, we can also view it as 4 times 3. So we can split this to having square root of 4 times the square root of 3, alright? Very nice, like that. Now, square root of 4 is the positive result 2 times square root of 3. So this right here can be written as 2 root 3. Okay, so you see this has a number multiplying with the square root of 3. And okay, so but they are the same. That is one of the things you should know, that they are the same. In fact, let me reduce this to the end, but that's not actually why we're here. But let me just do it. Let me clean this up. Now you keep this result, okay, 2 root 3. I'm going to show that these are the same because they're actually the same. Now, you see that 6 can be written as 2 times 3, alright? And then we multiply with square root of 2. Again, we are going to split this up. We're going to have square root of 2 times square root of 3 from this law, okay? And we multiply with this one already, square root of 2. So this is square root of 2 times square root of 2. That is square root of 2 squared, right? Multiply with square root of 3. Very nice, like that, right? So we see here that 2 is a positive number. It is greater than 0, and we are taking the square root. So it will be a real number. We raise that to power 2. In fact, this and this, we just cancel out nicely, and we're going to enter with 2 times square root of 3, which is just 2 root 3. So they are the same thing, alright? Okay, but that is not really it. So that was just to show you a lot of work. So when we just have a product, we have to split it. Okay, the same thing goes for the quotient. So we take the ratio of two numbers. Let me just put it down. When we have the nth root of a divided by b, this right here is the same thing as, well, we just have the nth root of a divided by the nth root of b, and that still holds, alright? Okay, so for example, when we have, let me just put it down for you guys to see real quick. When we have to take cube root, right, of let's say 8 over 27. Okay, so we have a fraction, all right, and it is a irrational number according to what we learned. Okay, so this can be split into the top and the bottom, so we can have cube root of the top divided by the cube root of the bottom. So that is what we are actually saying here. Well, we have A over B, then, okay. Now, take note that this right here works for some conditions where the inputs are negative and n is even. You remember that we treated that already, okay, when we're talking about the properties of rational exponents. So you go back there and check those ones, okay? So this one I'm just treating them without actually recalling those conditions because I have talked about them already. So we are just applying them here. That is why I will point out that this is positive, and this is odd. It will work. So you take note of those conditions when it wouldn't work, alright? So we know that the cube root of 8 is just 2. And then the cube root of 27 is just 3. So this is just a reduction, but this holds, alright? Okay, now I want you to know these ones. Maybe this is not actually one of them. I just wanted to show you guys these two. When we have the square root, let me use square root as a particular case, of a plus b, this is not the same as square root of a plus the square root of b. They are not equal, right? The same thing goes for when, let's say, they are being raised to some power. This is b to power n. It is not the same as the square root of a to power n plus square root of b to power n. It also works for their difference, alright? Either their sum or their difference. They are not the same. Okay, this will only be the same if one of these guys is 0. Alright? But it doesn't imply that they will be the same for all numbers. Alright? Yeah, and we are even talking about square root. That means that in fact, let me remove this minus because it's going to complicate our work. Now, when we're talking about square root, it means that the entry here should not be negative, should not be less than 0. So you also take note of that, right? But all in all, that is very nice. So we will be applying this, especially when we talk about sorts, alright? And then even rationalizing of denominators. But it is a nice place to end the video. Right, thanks for watching and please subscribe to my channel.